Question number 4. 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 and so on. So what is my an? My an is 1 divided by n times n plus 1. So how to approach such questions? I am going to write this in a different way. My numerator is 1. I can also write it as n plus 1 minus n. N minus n is 0. I am left with 1. So I can also write this particular fraction as n plus 1 minus n divided by n into n plus 1. Why did I do this? I am going to split it now. So I can write this as n plus 1 divided by n into n plus 1 minus n divided by n into n plus 1. You see what I have done? LCM edutha ennago, you will get back the same value. So I am just splitting it. So I can also write it as n divided by n into n plus 1 minus 1 divided by n into n plus 1 minus n divided by n into n plus 1. But my interest is these two terms should be together. This term should be written separately. Okay. So what do I have? N plus 1 divided by n into n plus 1 minus n divided by n into n plus 1. So what do I have? N plus 1 and n plus 1 gets cancelled. N and n gets cancelled. So this is 1 by n minus 1 by n plus 1. Basically this method is called the partial fraction method, which you're learning in your future classes, but this is a shortcut to do this. So what is your an? An is 1 by n minus 1 by n plus 1. Okay. Now what is your a1? This 1 minus 1 by 1 minus 1 by 1 plus 1, which is 2. What is your a2? It is 1 by 2 minus 1 by 2 plus 1, which is 3. What is your a3? It is 1 by 3 minus 1 by 3 plus 1, which is 4. Similarly, what is my an minus 1? It is 1 by n minus 1 minus 1 by n minus 1 plus 1. Minus 1 plus 1 goes off, so it is 1 by n. So what is an? 1 by n minus 1 by n plus 1. So what do? We take the summation. Summation k equals 1 to n of ak. What is it? a1 plus a2 plus a3 and so on. An minus 1 plus an. So now I am going to substitute the values. I am going to add all of these. So I have, what is my a1? 1 minus half. 1 minus half. What is my a2? Half minus 1 by 3. So it is plus half minus 1 by 3. What is my a3? 1 by 3 minus 1 by 4. So plus 1 by 3 minus 1 by 4 and so on. What is my an minus 1? It is 1 by n minus 1 minus 1 by n minus 1 by n. What is my an? Plus 1 by n minus 1 by n plus 1. So what do you see? Minus half plus half goes off. Minus 1 by 3 plus 1 by 3. Minus 1 by 4 ko plus 1 by 4 ஒன்னு இருக்கும் இங்க. 1 by n minus 1 க்கு you will have a previous term. Minus 1 by n plus 1 by n. So what am I left with? I am left with 1 minus 1 by n plus 1. So 1 minus 1 by n plus 1. When I take the LCM, I have n plus 1 minus 1 divided by n plus 1. So what do I have? 1 no minus 1 no poidum. So I am left with n divided by n plus 1. So this is my final answer. Okay. Question number 5. 5 square plus 6 square plus 7 square and so on plus 20 square. So this is not an infinite sequence until n terms abdila illa. They have given the last term. Okay. So now let me write my nth term. How do I write my nth term? How do I write my nth term? When n equals 1, how can I write my first term? My first term can be written as 1 plus 4 the whole square. How can my second term be written as 2 plus 4 the whole square? Which means these are my n values. So basically how can I write it? I can write it as n plus 4 the whole square. Okay. So 5 can be written as 1 plus 4. 6 can be written as 2 plus 4. 7 can be written as 3 plus 4. And how can 20 be written as? 20 can be written as 4 plus 16 the whole square. So this is my final n. My n starts from an where n equals 1 to n equals 16. Correct? I need a general term to do the summation. But my last term is already given, which I can write it as 4 plus 16, where my n is 16. So what is my number of terms? Total number of terms equals 16. Okay, let me have this aside. Let me solve the general equation. So my an equals, I'm going to open the bracket, a plus b the whole square. So a square plus b square plus 2ab. 2 times 4 is 8. So 8n. So I have ak equals k square plus 16 plus 8k square. So when I take the summation on both sides, I have sigma k equals 1 to n of ak equals summation of k equals 1 to n of k square plus summation of k equals 1 to n of, I'll write this, 8k square plus summation k equals 1 to n of 16. I'm just writing it in order, okay? Sorry, this is k, not k square, 8k plus 16. So what do I have? It is simplified panna, n into n plus 1 into 2n plus 1 divided by 6 plus 8 times n into n plus 1 divided by 2 plus 16 times n. Okay, I can cancel this 2 and 4. Now what is my value of n? This is my Sn. What is my value of n? When n equals 16, I have my summation of 16 terms is nothing but I'm going to substitute 16. So I have 16 times 16 plus 1 times 2 times 16 plus 1 divided by 6 plus 4 times 16 times 16 plus 1 plus 16 times 16. So I have 16 times 17. 16 2 is 32 times 33 divided by 6 plus 4 times 16 times 17 plus 16 times 16 is 256. Final answer when you solve this is 2840. That is my final answer. Question number 6. 3 into 8 plus 6 into 11 plus 9 into 14 and so on. So what is my an? What do you see? First terms it is 3, 6, 9 and so on. So they are multiples of 3. So how do you write multiples of 3? 3n. Okay. This is my first term. What is my second term? 8, 11, 14. How do they differ? 11 minus 8 is 3. 4 minus 11 is 3. So they differ by 3. So what I'm going to do is, I'm going to write 3n. When n equals 1, what do I have? 3 plus 5n. So I'll write plus 5. Now let's check for n equals 2. When n equals 2, I have 3 times 2 plus 5. So 3 to 6, 6 plus 5 is 11. So similarly, n equals 3, which means 3 times 3 plus 5, which is 9 plus 5, which is 14. So basically, 8 is 3 plus 5, 11 is 6 plus 5, 14 is 9 plus 5. So you need to find some pattern which satisfies all the numbers. So that is your an. Okay. So now your an becomes, when I multiply it inside, I have 9n square plus 15n. So what is my ak? 9k square plus 15k. So now use the formula that you know, taking summation on both sides of ak equals summation k equals 1 to n of 9k square plus summation k equals 1 to n of 15k. So I take my 9 outside. What is summation of k square? It is n into n plus 1 into 2n plus 1 divided by 6 plus 15 times, I have a constant. Summation of k is nothing but n into n plus 1 divided by 2. So I can cancel this. 3 2s are 3 3s are. So I need not take the LCM because I have the same denominators. Now I'm going to take n into n plus 1 outside. I'm going to take 3 into n plus 1 because I see a 15 here. So I'm going to take 3 outside, n into n plus 1 outside, also by 2. I'll take 3 by 2 times n into n plus 1 outside. So I'm left with, when I take 3n n plus 1 2 outside, I have 2n plus 1. In the இடத்துல, when I take 2 outside, n into n plus 1 outside, I'm left with 15. 3 எடுத்துட்டா, I'm left with 5. So I'm left with 2n plus 6. So what happens? This is 3n into n plus 1 divided by 2 of 2n plus 6. So I'm going to take the 2 outside. So I have 3 by 2 of n into n plus 1 times 2 of n plus 3. So the 2 and 2 gets cancelled. I'm left with 3n of n plus 1 times n plus 3. You have to find how your an looks like. That's the major problem. When you find this out, you can just simply solve them. Okay.